All right, now we're going to move on to the fun stuff, solving real-world problems with these absolute value inequalities. So absolute value inequalities are often used to model real-world situations involving a margin of error or tolerance. Tolerance is the allowable amount of variation in a quantity. So if we have our example here, a machine at a lumber mill cuts boards that are 3.25 meters long. It is acceptable for the length to differ from this value by at most 0.02 meters. So some of the important information we're looking at here, boards are being cut to be 3.25 meters, and the length can differ by at most 0.02 meters. So if we let the length of the board be L, since the sign of the difference between L and 3.25 doesn't matter, we take the absolute value of the difference. It's kind of easier that way. Since the absolute value of the difference can be at most 0.02, that means our absolute value would be L minus 3.25 has to be less than or equal to that 0.02. So then to solve, we're going to split it up. Again, this is the time where I'm just going to immediately write it in between the negative and the positive. You can do it their way if you prefer, but you should find out that the L value should be greater than or equal to 3.23 or less than or equal to 3.27. So those are the values we'll need to be in between 3.23 less than or equal to L, which is less than or equal to 3.27. And pretty much all of these will be set up the exact same way as we just did. The bounds of the range are positive and close to that 3.25 original amount they're being cut at, so this is a reasonable answer. And we know this answer is correct because when we take 3.23 and add 0.02, we get 3.25. Or if we take the 3.27 and subtract the 0.02, we get our 3.25. So one more quick example here to finish this up. So a box of cereal is supposed to weigh 13.8 ounces, but it's acceptable for the weight to vary as much as 0.1 ounce. So we want to write this as an inequality. So I'm going to let W equal the weight of the cereal. So when I set up my absolute value, whatever my weight is, I'm going to subtract what it's supposed to be, 13.8, stick it inside my absolute value, and then I know it needs to be less than or equal to that amount it can vary by, that 0.1. So I'm going to go ahead and stick it in between my positive and my negative 0.1s. So then you can add that 13.8 to both sides to your solution. 13.7 less than or equal to W, which is less than or equal to 13.9. And that's it. Make sure if you have any questions, feel free to email me.